All right, let's go over this extra practice for the first part of our descriptive data unit. So here we have this first problem, and we know this is the percentage, the relative frequency. And so it wanted to know Google or Google Scholar out of those 1106. So it was that percent of the 1106. All right, so we added those together. Now, if it had asked for like two of these sections, then you could add those percentages together total and then get that overall amount. All right, next we had 10 different schools and you selected all of those. So those were clusters. So that was a cluster. Here, you had to determine if you had an outlier. You have got to actually compute all of the information. You can't just go, looks like there isn't one. No, you have to do that. So I put all of these into my calculator list one, and I computed that 5-number summary so that I could get the IQR and then the fences. And then I went and evaluated. There were no values below the lower fence or above the upper fence, so there were no outliers. Okay, you have to do that specific computing. You can't just gauge it by looking at it. All right, which of the following is not true? Okay, so looking at that, the males. Oh, I think this page actually did not copy off on your work yesterday, but let's go ahead and we'll take a look at these ones that I had. You didn't have this. So this was males and females and their weights, which of the following was not true. So the first one, 50% of males weigh between 50 and 80%. Yes, it was this middle quartile between 50 and or IQR interquartile range. So that was correct. 25% of the females weigh more than 130. So that was here, this top quartile for the females. The median weight of the males is about 162, and that is correct. And this says the male students' weight have less variability than the females. And I can see this is a wider range, so we definitely have more variability amongst the males than the females. Now, this problem here, you also did not have, and I think I'm not going to worry too much about this one. We'll actually get into this concept more when we go to into probability. Yeah, so we'll get that covered later. FYI, I think your problem 10 that you had was similar to this, so we'll take a look at that in a minute. Next, number 6. So this was an experiment because the students were randomly assigned to one of the treatments. The explanatory variable were the two types of programs, the either simulated dissection or the actual dissection. Response was that change in the test score, not just test score, that difference between their test scores, post-test minus pre-test. Important that it's the change. All right. Now, this had said, what happens if the teacher let them choose? What might happen? And it wanted to know, describe a confounding variable. So you needed to be specific of a made up scenario that could happen if students chose their particular type of dissection. So here we go. If students were allowed to choose their instructional program, then certain types of students might be more prone to choose a particular program type. Okay, for example, if more studious students are also students who are conservative, they might all choose the virtual dissection program. That would make the change in test scores be higher because the more studious students happen to all be the virtual dissection group who want to learn more and get high test grades. So they're going to do better because they're the more studious, making sure that they know the material. All right. So giving a specific example there. Here, we had these ones here. Here it was the D was the answer, which is the true one. The highest female quartile spreads about 40 years, and the highest male quartile spreads about 23 years. So the highest 25% is more spread out than the males. Here you can see why I said that the other ones are not true. So you could stop and take a look at that. Keep in mind that when we have our box plot, we don't know how many people are represented in each one of these box plots. So I can't compare the number of people, the number of males, and the number of females. Very important thing to understand and distinguish, okay? Cannot tell the number unless they gave us the total. All right, here we go. So on this one, which statements are true? So the range of the sample is always going to be the same or less than the range of the population because that sample will always be a subset of that population. Okay. 2 is not true. The IQR is Q3 minus Q1. 3 is true. The range, that outer edges, those are affected by outliers when you have those numbers way out here. Okay. But the IQR is not, because when you get the IQR, you're knocking off those outside edges to get to that middle 50%. So the Q1 and Q3, they're protected. They are not affected by anything crazy going out here on the outside edges. So 1 and 3 are true statements. All right. Now, one key thing to understand in this chart is that when you looked here at this sentence here, that the pie chart is providing information about the manufacturer cars in this use by the Consumers Union. Okay, so this chart is not telling you something about gas mileage, even though they mentioned gas mileage in this topic. Okay, so this chart is just telling you the location of where these cars are manufactured. So therefore, you can see that A is no good, B and C. All of those are talking about gas mileage, of with which this chart is not telling us. The Mercedes, Audi, Porsche, and BMW, I mean, I'm not exactly sure where all those are coming from. I'm assuming they're trying to tell me something about these other countries and that kind of stuff. But I mean, we don't know that that's all of the cars that were tested in those countries anyway. So the best answer is that we do know is that more than half of that picture are cars. See this area here are cars from the US. All right. Next. Okay, this one I marked off because it was a duplicate of the other one that I went over in problem number 4. But I think because you happen to have 4 and 5 missing this year, the copier didn't copy it, then let's take a look at this. So A and B and C are true. Now this one's interesting. D says the average weight of the females is about 120. And then this says the males have less variability than the females. Okay. So E is definitely, again, the one that is not correct. Now, we haven't talked about this component with D. That's why I told you to omit this one. Number 4, I left that question statement D off. So look here. The average weight of females is 120. Well, we know here that the median weight of the females is 120, and we haven't talked yet about that relationship between the median and the mean based on the shape of the data. We'll learn later that because this is somewhat symmetric, the mean and the median are about the same. So that's why the mean is also 120 like the median. Okay, so we'll get into that more in this next more enriched unit that we come up with. 11. So here, so a lot of people were asking me about C. No on this identical result. C is no go because you're not going to get identical results from an experiment to an experiment. They vary from sample to sample. But E is like a matched pairing of those cuts into those different types of time temperature combinations. All right, here on number 12, the 200 seniors puts the median in between that top 100 and bottom 100. That's the average of the 100 and the 101th height. That's there then in this 60 to 66 inch height. All right, so this is interesting. So they're not asking you if gender and eye color are independent. They're telling you, hey, we had this data and they are independent. So what that is telling you is that since right here, since the gender is independent of eye color in this experiment or in this data set, they're telling you it is, okay? They're not asking you. So since the gender is independent, then independent, the fact that you are one thing does not change the rate. So here, if 60 out of 80, which is 75%, have brown eyes for males, then it's not changing the rate for females. So I need to go with that same rate for females. So the females have 75% brown eyed individuals as well. So that's why 75% of 120 is 90. Next, here we have this. I'm taking out the words that are not true. Here again, we cannot compare the number of items in these two. I do not know how many were represented in these two box plots. Okay. And now the range, okay, is not less. This was median was not twice as much. And those ones were not both classified. B is the one that was correct. The IQR of the healthy is bigger than the IQR of the regular. All right. Now, uh, here on this one, okay, which is the following statement must be true. So it was C. At least half of the women had higher pulse rates. So what they're referencing is this. So this top 50% of the women had higher pulse rates than 3/4 of the men. Okay. And so that's saying that half is more than this bottom 3/4 of the men. Okay. So that was the one that was true. Again, we do not know there are more people because we don't know the amount, or hold on a second, maybe we did. Yeah, there it did tell us in this case there were 20 men and 20 women. So we actually know how many are in the quartiles here. The lowest was the men, more than, and then these other ones, you can just look at those percentages and see that those were not correct. All right, number 16. Okay, yeah, that was 15. All right, number 16 here we don't know the number of students in any of these categories. Keep that in mind. Okay, we don't know how many eighth graders, how many seventh graders, how many sixth graders. Okay, but what's interesting is, and I fell victim to this, I wanted to just automatically knock off the number. Okay, but if we looked at part D, it actually is comparing completely in seventh grade. So it's comparing the number who chose activity C in seventh grade to the number who chose activity B in seventh grade. So in that case, because they are both of the same total, then I can say that this C proportion is a higher proportion of the total than that B proportion is of the same total. So the catch to why answer choice D is correct is because it in both cases it was talking about seventh grade. Okay, you couldn't do any comparisons between seventh and eighth graders, um, and now E compares eighth to eighth, but it wasn't correct. It said A was more than activity B. Okay, and then here in B compared seventh against eighth, can't do that. And of all of the students, we don't know about how all of them compare to what's in sixth grade. Okay, very important thing to distinguish there. Here we have number 17. Answer was C, the only one we know. I kind of put the reasons that these other ones were wrong. What was the deal with D? The max number of visits at community college is greater than the max at the high school. So, yeah, no, the max at the high school was the highest. All right, C. Yes, we can see that the spread for the four-year college IQR, that middle 50%, is less than the community college IQR. And so that was the four-year college IQR, which is interesting. There's no whiskers. and is less than the spread for the community college IQR. All right, 18. Okay, so here, each of these dots is a piece of data. So I knew that I had 28. So I actually went through and I counted and I put a line where the median was. So the median was in between the top 14 and the bottom 14. And then I split 7 and 7, 7 below and 7 above the Q1. And again, 7 below and 7 above the Q3. Okay, so I went in there and I drew a little line where exactly those items were. That way, I could then see that the only difference between this was the range, with the exception of this says oh, hold on a second. I think I have this wrong. No, so I had to fix something. So actually, so this one, the IQR, that's not right. The IQR there was the same. Okay. So yeah, the IQRs for all of the interquartile range, nope, it was also the same. Okay. So all of them are the same except for the overall range. All right. How is this misleading? Well, you've just got to look here and see this is a violation of the area principle. Here, this week 4 looks like it's at least a fourth as much as week 1, but yet it's only about 13 points higher. Okay. So, because this graph is starting at 196 rather than 0, then we don't have that correct proportional relationship amongst those. All right, and then our last one, number 20. Here were our different probabilities, so marginal. Okay, so the question then keeps arising is, how do I know which way to do my fractions? Okay, so between you being in the, we are thinking that the fact that you're in the environmental club or not would impact or could affect whether you decide to rent or own or even use a snowmobile. Okay, those who are very environmentally conscious might not want to then, use that vehicle and get that out there on the terrain and do some pollution out there. Okay. So, because of that, we have this supposition that the environmental club, whether your environmental club, might affect your usage or your role that you do with snowmobiles. So, we're going to do our fractions in this direction. So, for our marginal, of course, is going to be here. That's our marginal, and because that's out of the totals. And so that's why I have here. See, that's out of the total 1526. Overall, 44% have never used. Overall, 37.6% have been renters, and overall, 19% have owned. Okay, but then we get into this section here. This is conditional upon you having owned a being or conditional upon you being in the environmental club or not. What's the rate at which you do things? Okay. So here, this was out of the denominator of 1221. All of these in the no category were out of a denominator of 1221. All of these were out of the 305 who were in the environmental club. All right, so you can see then how I did those proportions. So in order to determine this relationship, we are comparing all of these to their respective marginal. So I would be comparing these two amounts, to this one. So I'm comparing 36.3 and 69. So you are way more likely to have not used, almost twice as likely to not use a snowmobile if you are in the environmental club. Okay. But definitely much more than overall. Okay. And so on. And then in the other ones here, this here with this right here, we're going to be comparing here. So you are definitely less likely to have rented if you're in the environmental club, more likely to have rented if you're not. And then, of course, look at this here. So much different proportions owning. So the fact that you are in the environmental club is definitely changing the rate at which you are doing things. So here I go on my full conclusion and write up to how you need to do this. Okay, you want to include these three things. So the question is there evidence of an association between environmental club membership and snowmobile use? Answer the question. Yes, there appears to be an association between environmental club membership and snowmobile usage. Okay. Second, elaborate on there. The fact that you are or are not in the environmental club affects the rate at which you do not use, rent, or own a snowmobile. That's your elaboration statement. And then the final one is specific numerical examples for all categories. Being in the environmental club makes you almost twice as likely to have a snowmobile. Now, you know what is interesting that I did, and I've kind of told you to not do this, but I did it. I actually was comparing the conditional to conditional. Now, I did mention in class that when there are just two conditional items, the no in the yes or male and female, you can compare them to each other. It's if there was another category here. If there were three or more conditional categories, you would have to compare to the marginal. Okay. Because you could have one subcategory that's independent while the others are not. Okay. Anyway, so I happen to compare no and yes, environmental club or not. Okay. And so then I also talked about how the ones who are not in the environmental club are much more likely to rent a snowmobile, and the ones and almost four times as likely to own a snowmobile. And then I stated specific numerical comparisons. Okay. All right. So make sure you take care of those details whenever you get ready to statistically support your decision.